Hi everybody. This is Bharat, Assistant Professor, Department of Electrical Electronics Engineering, SNS College of Technology, Coimbatore. In our lecture series of electric circuit analysis, the second video, what we are going to see about is the basic concepts of Kirchhoff's law. In the previous video, we have defined the elementary concepts of electric circuit analysis, that is of basic circuit analysis. Today, we are going to discuss about what is this Kirchhoff's law. Now let's get into the video. What are the topics that we are going to discuss today is the Kirchhoff's law, Kirchhoff's current law, Kirchhoff's voltage law, and some problems associated with this Kirchhoff's current law and voltage law. So as a recap of the previous session, what is Ohm's law? So as we know all per definition, at a constant temperature, the voltage gives a relation between current and resistance. That is, V is directly proportional to current and resistance. That is, V is equal to I into R, which defines the Ohm's law. So with this small recap, we just get into what do you mean by the two laws of Kirchhoff's. The Kirchhoff's current law states that the sum of the current entering into a node, that is a junction point, is equal to the sum of the current leaving the node. This Kirchhoff's current law can also be stated as the sum of the currents at a junction point is equal to 0. With a small analogy, you can see a circuit that is IA, IB, IC, and ID can reach either a positive or a negative number having at the junction point at the point O. So the equation of this circuit can be written as IA plus IB is equal to IC plus ID. This is called Kirchhoff's current law. What is Kirchhoff's voltage law? So this law depends upon the value of voltage, that is, algebraic sum of the voltage around each loop is equal to 0. The potential rise is equal to potential drop is also a type of definition given to Kirchhoff's voltage law. That is, the sum of drops minus sum of rise is equal to 0, or voltage drop is equal to voltage rise. Let us see this with a small example. Kirchhoff's voltage law around the loop 1. So consider this circuit. What is the Kirchhoff's voltage law for the loop 1? Having an voltage source of rise Vs and two drops of having a current of I1 and I2 through a resistance R1 and R2. So how will we write the voltage expression for the first loop? We can write and assign the values of current variables and directions. Use Ohm's law to assign voltage and polarities consistent with passive devices. Current enters a site. So you can give the values of plus, minus as like the source to the resistance, that is I1 into R1. Similarly, I2 into R2. So the overall equation could be written as the starting of first voltage source drop I1 R1, second voltage source drop I2 R2, which is minus Vs equal to 0, or Vs is equal to I1 R1 plus I2 R2. So this is called Kirchhoff's voltage law. So subtract the voltage rise from C to A through Vs. Having that in mind, we see some examples of Kirchhoff's voltage law and Kirchhoff's current law. Consider the circuit shown in the figure with a 20-volt voltage source, 2 amps current passing through a resistance of 5 ohms and 3 ohms respectively. And another resistance of 2 ohms also added in the circuit. Now, find out the value of voltage drops at different points of the resistance. I into R drops. So each the value of current flowing through a circuit is 2 amps, and the resistance value is given as pi, 3, and 2. So I into R, multiply 5 into 2, you get 10, 3 into 2, 6, 2 into 2, 4. So the voltage drops are 10, 6, and 2. And the current flowing through the circuit, the voltage at the source is equal to 20. So voltage rise is equal to voltage drop. So 10 plus 6 plus 4, which is equal to 20. So voltage rise is equal to voltage drop in the given circuit. Second example, we have a 10-volt source which is passing through a junction point. The current and it moves out from the junction point, which has two resistance values of 5 ohms and 6 ohms respectively. So what is the total current is out of the circuit is 3.7. So when we calculate at the junction point, I5 and I6, which is equal to V by 5, that is 10 by 5 is equal to 2 amps, and V by 6, that is 10 by 6 is equal to 1.7 amps. The total of 3.7 amps is equal to 2 plus 1.7, which is equal to 3.7 amps. So as per the Kirchhoff's current law, sum of the current entering the circuit has divided in both the sides, that is, sum of the current leaving the circuit. So as a total, R equivalent is equal to R of both the resistors are in parallel, R1, R2 divided by R1 plus R2. So total 30 divided by 11, we get at 2.7. So 10 by 2.7 is equal to 3.7. So on both the sides, we have confirmed that 3.7 is the value. So Kirchhoff's current law is also determined or verified using the above circuit. Another example where we have 74 volt source, 5 ohms, 4 ohms, and 6 ohm resistance. So two resistors are connected parallelly, and one resistor is connected in series. Total of 7.4 resistance. So 74 divided by 7.4, we get a 10 amps of current. So with these few examples, we just discussed about the various concepts of electric circuit analysis. So in this video, we come to an end. What is the summary? We get know about what is Kirchhoff's current law, Kirchhoff's voltage law, and we have done some example problems to verify Kirchhoff's current law and voltage law. Thank you. Let us meet in the next video.